Hello, this is Jack Jackson. Today we're going to be looking at the AAS condition with triangles. Now remember what we're doing is first of all, this is part of a sketch that I have written called Triangles Ultimate. And we're looking at we've been looking at the congruent triangles. Remember, two triangles are congruent if and only if all 6 of the measurements match up, so that you have 2 sides are congruent, a pair of sides are congruent, another pair of sides are congruent, and the third pair of sides are congruent between the 2 triangles. And similarly, all the corresponding angles are congruent. So there's 6 things there that must match up for those 2 triangles to be congruent. And we've already looked at the underlying question here is which of these conditions, when you have 3 sets of congruencies, so the question is, when we have 3 of these sets of congruencies, when is that enough to make all the other 3 congruent as well? We looked at the SAS and the SSS properties in an earlier video, and now we're going to look at the AAS. So this time we're given, one way we can look at it is we're given 2 angle measurements and a side measurement. Now notice the way this is, the notation here, this first angle measurement, whatever it is, has to be opposite this side here. So the way we're doing in this notation, capital A is the angle that's opposite side A. So this slider ultimately is going to specify a slide length. This angle is going to do the opposite angle of this side, and this B here will be one of the adjacent angles. Actually, it doesn't matter which one, because you can read it around either direction. So you've got an angle, and then a side. Now, this is a little difficult to draw directly by hand, but we can do it with Geometry Sketchpad. Okay, so what we're going to do is we're going to construct in this order side, angle, angle actually. So we're going to start by constructing a side of this length A, and there it is. Now we have 2 of the vertices, both B and C. Now we need to figure out where vertex A is opposite the side of length A. So the angle A is going to be, up here somewhere opposite this side, and we're going to put angle B. We can put it either here. Well, we'll put it here at B. So that's the next step, is we draw that angle. So we know we have 2 of the vertices, B and C, and we know the third vertex is somewhere on this side. So what we want to do is we want to pick a value for A somewhere on this side. But what do we have to have? We have to have this angle. See, this angle right here determines that. This angle determines the angle at B, and this one determines the side length here. Okay, so let's take a look what we've got. We know once this angle A is fixed, we can move A up and down here, and we get that angle. But where this side here meets this ray down here has got to be our vertex C, but C has to be there. Well, how many places can we do that? Well, the only place is right there when they land on top of each other. And so that's the only triangle that you can come up with that setup. Now if we were to do this by hand, we could start pretty easily. We could make a line segment here with our ruler. We could make this ray using our protractor. But making this one's a little difficult because we'd have to set our protractor up here with a ruler and slide it up and down until we met that point, which is kind of difficult to do by hand, but we can do it here in Sketchpad. And so we end up with, there is our triangle. That's the only one that's going to work. That's one way we can go at this. Another way we can go at it is this way. So again, we start by drawing our line segment BC and our angle B. So that part's the same this way. But this time we know that A has to go through point C, and what we can do is we can move this up and down. But notice now what happens, it changes this angle. And so what do we have to do? We have to match the right angle, so the correct angle. So there it's way too big, so we got to match these 2 green measurements. So this is 115, that's 52, roughly. Okay, too big. Over here it's too small. Where is it just right? Only one place. I don't know if I can get it exactly right, but so that's pretty close right there. So there's some place right in there where it's just right, and that makes our final triangle. So either way we investigate that, we can get it by sliding the this point till it lines up just right, or we can slide this point here until we get the angle right. So we can either fix the angle and try to slide this point over till it lines up, or we can slide leave the point at C fix and slide this till we get the angle right. Either way you do it, there's really only one place that it's going to show up. Now then, so here's our final get this just the right place, it'll show up. Okay, so there's our final thing. What happens if we change this angle? Can we always make this work out? Okay, well, are there any possible exceptions? Okay, so again, let's put this in here. Well, there is a possibility where we could run into a problem. And the only problem that's possible is basically here, is if both of these angles are too big. Now we have a problem because it has to be, point A has to be on this ray, but it also has to be on this ray here. Let's see. It's not. If these two angles are too big, then there's not enough space for the smaller angle. Let's see which way is the best way. Yeah. So this ray here has to go down and intersect this side. And you can see the angles are such that there's no way that's going to happen. So if this angle's too big, that's going to happen. If we can make this angle come in smaller, then some point it's going to be small enough that, yeah, it will eventually come down and hit that side, and then if we bring it in small enough, it'll get our triangle that we need, which is right there. So the bottom line is this: if these two angles add up to less than 180 degrees or less than pi radians, then there will be enough space for the third angle, and this ray will come down and touch this ray here somewhere. But if the two angles add up to more than to equal to 180, then these are actually parallel to each other. And if it's a little bit bigger than 180, then they diverge, and so that there's nowhere for them to touch. So, bottom line is, not surprising, if the two angles add up to more than 180 degrees or more, then that's not possible, right? Because the three angles have to add up to 180 degrees exactly. So we can mess this up, but the only way we can mess it up is by giving two angles that are too big to begin with. So the congruence theorem that we have is this: if we're given any two proper angle measurements, and one side where the first angle measures is to be the measure of the angle opposite the given side length, then either zero triangles are possible if the sum of the two given angle measurements is greater than or equal to pi, or 180 degrees, and otherwise we get one triangle size possible if the sum of the two given angle measures is less than pi over pi, which equals 180 degrees. Now, so that's thinking of if you're given the actual measurements. The other way we can think of it is if we're given two triangles with two pair of corresponding congruent angles and one pair of congruent sides where the sides opposite the first pair of corresponding congruent angles are congruent, that's the AAS condition, then the two triangles have to be congruent. So AAS is enough to guarantee congruence of triangles. So we'll stop here. We'll come back and look at the next tab to continue this investigation in our next video.